Welcome everybody. This is Math 103, Section 1.4 on exponents and the order of operations agreement. So recall that exponents represent repeated multiplication, and they consist of a base and an exponent. The base is the number that we multiply over and over again, and the exponent represents how many times that number appears in the multiplication. For example, 3 to the 4th power, 3 is the number we're multiplying over and over again, and it appears 4 times. And now we're going to do the reverse in your turn number 1. Now keep in mind, I'm not going to pause the video to allow you time to work on the your turn. So you should pause the video here and do the your turn, and then resume the video when you're done. Your turn number 1, we've got x's being multiplied repeatedly, so that's the base. And x appears 3 times, so the exponent is 3. X to the 3rd power. And we can also apply exponents to fractions. So 4/5 to the 3rd power, this represents repeated multiplication of the fraction 4/5. The entire fraction 4/5 is the base. So this is 4/5 times 4/5 times 4/5. And since with fractions, we multiply straight across, up on top we have 4 to the 3rd power, and on the bottom we have 5 to the 3rd power. And evaluating that gives us 64 over 125. And this fraction cannot be simplified, so that would be the final answer. Your turn number 2. We have 3/7 squared. You can turn that into 3 squared on top and 7 squared on the bottom. And evaluating, we have 9 over 49. Now with exponents, be very careful when you encounter negatives. So if we take a negative and raise it to an even power, such as in the next example, we got negative 3 to the 4th power. The base is negative 3. You have to include the negative when we do the repeated multiplication. Now in this case, we've got pairs of negatives here that are going to cancel each other out. Negative times negative is a positive. So that turns positive, and that turns positive. So we get positive 81 for that one. But if we take negative 3 to the 5th power, then these negatives are going to cancel here. These negatives are going to cancel, and we're left with one negative remaining. So that's going to stay in our answer. That one doesn't get to cancel with anything. So we get negative 243. Now let's compare that with this situation, where we've got one number in parentheses and one number outside of the parentheses. All right, no parentheses here, parentheses here. Two very different situations because the base is different in those two expressions. So this is where paying very close attention to the symbols is critical. The base is only the thing right next to the exponent. So that negative has nothing to do with the exponent here. So this expression can be written as negative times 2 times 2 times 2 times 2. So we multiply these out, 2, 4, 8, 16, but it's still negative. So we get negative 16 here. But with this expression, the base is negative 2. So this represents negative 2 times negative 2 times negative 2 times negative 2. Now, just like we saw over here, the negatives all cancel because we have an even number of negatives. And that one is positive 16. Your turn, number 3. So just like we saw with the example, here we've got a base with a negative. All those negatives are going to cancel, and we get positive 1296. But with here, the base is just 6, and we're multiplying by negative 1. So negative 1 times 4 6s multiplied is negative 1296. So let's say your friend gives you directions to a restaurant. Turn left, then left again, then right, and you're there. Instead, you turn right, then left again, and you're lost. Order matters, and it's critical in math. So that's why we have the order of operations agreement. With any expression, using the order of operations agreement, we're all going to evaluate the expression the exact same way in the same order. So let's compare 2 different ways of evaluating the same expression. We got 20 divided by 5 times 2. So what I'd like you to do is here divide first. And here multiply first and see what you get. So if we divide first, 20 divided by 5 is 4. So we get 4 times 2. 4 times 2 is 8. If we multiply first, we get 20 divided by 5 times 2 is 10. 20 divided by 10 is 2. So just like we end up at a different place if we follow the directions in a different order, here we end up at a different answer if we do the operations in a different order. So that brings us to the order of operations agreement. So have a look at that. We're starting with grouping symbols. So that's in kind of parentheses, brackets, absolute value, division bar. And then we do the order of operations inside any grouping symbols, starting with exponentials, multiplication, division, working left to right, addition, subtraction, working left to right. So let's practice. Start off with an example. 4 times 6 minus 18 divided by 3. So we don't have any exponents, don't have any grouping symbols, so we're going to start with multiplication, division. We'll work left to right. Here we'll start with 4 times 6, get 24. All right, now we've got a division here, so we're not going to do the subtraction first. We don't work left to right when we're working within different steps of the order of operations agreement. All right. Subtraction, that has to wait till the end. So we're going to do this one first. So 18 divided by 3 is 6. So we get 24 minus 6, and then we do the subtraction and get 18. Your turn, number 4. So we got no grouping symbols, no exponents. We'll start with the division on the left. 24 divided by 3 is 8. Now we'll do the multiplication. Then add them together, and we get 20. Next example. Twelve divided by 6 times 2 plus 7. Again, no grouping symbols, no exponents. Start on the left with this division. 12 divided by 6 is 2. From left to right, and I would do the multiplication, so that's 4 plus 7, and then finally the addition to get 11. Your turn, number 5. All right, starting from the left, we got division here. 22 divided by 2 is 11. So that gives us 11 times 3 plus 4. Now do the multiplication. 11 times 3 is 33. Plus 4. And then finally the addition to get 37. Now with this expression, we see our first grouping symbol, and that's the absolute value bars. So we're going to have to evaluate inside here first. So when I'm doing that, what I'm doing is writing everything else down exactly as it's written in the first step. That keeps everything organized. What I see some students do is just do this, write it over here, then they try to fill it in on the next step. That's a bad form. You should write everything down on every step. So here we got 2 minus 4, which is negative 2. So we got the absolute value of negative 2. Now we're going to evaluate this, and anytime you have a number right outside of a grouping symbol, this is multiplication. So once we evaluate the absolute value of negative 2 to be 2, we're going to end up with 3 times 2 here. So that's 16 divided by 4 plus 3 times 2. All right, now that we've gotten rid of the grouping symbol, now we've got some expressions that look like the ones we've done before. So we'll do it just like we did with those. So 16 divided by 4 is 4. And then 3 times 2 is 6. So we got 4 plus 6, and then 10. Your turn, number 6. So we've got grouping symbols here, so I'm going to start within here. 18 plus negative 30 is negative 12. Now we'll continue within the grouping symbol, evaluate this to be positive 12. And now we've got division Multiplication over here, start on the left, and get 6 here, 6 minus 6 times -1. Now we do this multiplication. Now we have to be very careful here. So I'm going to bring down these two things that we're not working on, 6 minus. And then over here, when we take 6 times -1, we get -6. So that should go inside parentheses. The mistake I see here is just 6 minus 6 and getting 0. So make sure you understand that that negative and that negative are separate. They should not be combined until the next step. Now we're going to combine them because subtracting the negatives is like adding, so that's 6 plus 6. And final answer is 12. Next example, we've got our first exponent. So we've got 5 times -2 squared. So we'll start with the exponent. We're squaring -2. -2 is the base, so that's -2 times -2, so that's going to turn into a +4. So 5 times 4, or 20. Your turn number 7. So again, we'll start with the exponent. This time we have -2 to the third power. So that's a negative times a negative times a negative. We have 3 negatives. Since it's an odd number of negatives, the result will be negative. So here we get -3 times -8. Now negative times negative is a positive. So those negatives cancel and we get positive 24 for the answer for that one. Next up, now we're going to mix in some grouping symbols and exponents. So start within the grouping symbols. Now within this grouping symbol, I'm going to apply the order of operations agreement. Right? We've got subtraction and division. We're going to start with the division. Everything else comes down unchanged. 18 divided by 2 is 9, so we get 12 minus 9 inside the parentheses there. And over here, a minus 10 is -2. -2 to the third power. All right, now complete inside this grouping symbol. So 9 divided by 3. Everything else stays the same. Grouping symbols are done. Now we can move on to the exponent. -2 to the third power is -8. Now we're down to division, subtraction, multiplication. So we're going to do the division first. Now the multiplication. 3 times -8 is -24. That should go inside parentheses. Now we are subtracting a negative, so that's adding. So 3 plus 24, or 27. Your turn number 8. So we're going to work inside these grouping symbols first. Here I've got subtraction and an exponent, so we'll do the exponent first. (20 minus 21), that's -1. So -1 to the third power on the end. I'm going to complete this within this grouping symbol first. So that's 5 there. All right, now we'll do the exponent. -1 to the third power is -1. Now we've got division, addition, multiplication. So we'll do the division on the left. 3 plus 3 times -1. Do this multiplication, we get 3 plus negative 3. Those are additive inverses. Add them together and we get 0. The next expressions we're going to look at involve nested parentheses, and that is parentheses within parentheses. So when we have parentheses within parentheses, we're going to start with the inside parentheses. We're going to simplify as much as possible here before we do things like distribution. So 3 plus 1 is 4, and that takes care of the inner parentheses. Now we're going to work inside this grouping symbol. So we've got subtraction and multiplication, so we'll do the multiplication first. Now we can complete inside these parentheses. So that's 2 times 18. And finally, 2 times 18 is 36. Your turn, number 9. So I'm just going to copy everything down exactly as it appears, except for what I'm going to actually operate on, which is inside the inner parentheses. 4 plus 8 gives us 12 there. Now inside this grouping symbol, now we have multiplication, so that is 36 minus 24. So that gives us 9 times 12. We do 36 minus 24, and 9 times 12 is 108. The next type of expressions involve fraction bars. The fraction bar is a grouping symbol, so that means we can work on the top and the bottom independently. And the goal with an expression like this is to simplify the numerator down to a single number and then simplify the denominator down to a single number. Once we have single numbers on top and the bottom, then we can divide. So on top, we're going to start within the grouping symbol, so that is 5 times 6 minus 6 over, here we'll start with multiplication. 2 times negative 8 is negative 16. Negative 16 plus 10 on the bottom. All right, next up, on top, we have multiplication, so we'll start here. Do 30 minus 6 over negative 16 plus 10 is negative 6. Now we'll finish off the top to get 24. So we got 24 over negative 6. And now we're down to a single number on top, single number on the bottom. Now we can divide. So 24 divided by negative 6 is negative 4. Your turn, number 10. On top, we'll start within the parentheses. So you get 2 times 15 plus 2. And the bottom will start here, multiplication, so that is 15 plus 1. Now on top we have a multiplication here, so we'll do that next. That is 30 plus 2, and on the bottom we get 16. Completing the top, that is 32 over 16. And now we're down to a single number on top, a single number on the bottom. We can divide to get 2. Hey everyone, this is Math 103 and we're working on section 2.1 today on evaluating variable expressions. Many quantities in fields such as business and science can be found using variable expressions. These expressions, they represent known relationships between various quantities. And once we find out the values of the variables, we can plug them into the expression and determine the value of the quantity we're looking for. So let's look at a couple of examples. First example, the owner of a food stand is selling fresh baked pretzels at $2.50 and soda pop at $1.25. So at the end of the day, the owner figures out how many of each item they sold, wants to calculate the total revenue, which is the income. And the other example from chemistry lab, a student is studying a sample of krypton gas at a certain pressure. How many moles of the gas are in the container? So these are some examples of some of the things we can calculate. So our objectives today, we want to evaluate algebraic expressions given values for their variables. So we're going to be plugging the values in and then using order of operations that we learned before to find the value. We'll start off with some vocabulary. So I'll look at this expression here. This is called a variable expression because it's an algebraic expression that contains variables. A constant, fixed, unchanging number. So the constant in this expression would be the number without a variable part next to it. So it would be -9. Make sure you include the sign. A variable, it's a symbol that represents an unknown quantity. So x and y would be the variables. A term. A term is a collection of numbers and variables separated by addition, subtraction, or the equal sign. So one of them is 2x. There's a term. 4y is also a term. And then keeping the sign with it, -9 is also a term. This will be important later when we're doing distribution, where you have to multiply a number by each term, so make sure you can identify what a term is. The variable part, the collection of one or more variables and their exponents in a term. So the variable part of this term, 2x, would be x. And the variable part of this term, 4y, would be y. And the constant term, it doesn't have a variable part. A variable term made up of a constant and a variable part. So here's a variable term, here's a variable term. This is not a variable term. This is called the constant term. Coefficient, number in a term. So coefficient in the first term is 2. Coefficient in the second term is 4. Algebraic expression, that's the entire collection of constants and variables and operations. So 2x plus 4y minus 9 is a variable expression. Evaluate to find the value of an expression. So if we knew the values of x and y, we could plug them in and find the value. So let's practice identifying some of these parts. We're going to name the terms of the variable expression and identify the constant term. -12 plus 5x squared minus 3x. So we have three terms. We have -12 as a term, 5x squared as a term, and -3x is a term. Now the constant term and is -12, and the other two would be variable terms. Your turn, number 1. Name the terms of the variable expression. Identify the constant term of 6x plus 9 minus 5 x to the third power. terms here, we got 6x, 9, and negative 5x to the third power. And the constant term is positive 9. Now in the next one, we're going to name the variable terms in the expression, and then we're going to identify the variable parts and the coefficients. All right, so there are two variable terms in this expression. There's 3x squared y and negative 4x squared y to the fourth. 7x, the constant term, so that's not a variable term. Now we're going to identify the coefficients of the variable parts. So the coefficients are the numbers. So coefficients would be 3, and keeping the sign with it, negative 4. And the variable parts are x squared y, it's the entire collection of variables and exponents, so x squared y here, and the variable part here is x squared y to the fourth. Your turn number 2. So our two variable terms will be 6xy to the fourth and negative 5x squared z. The coefficients are 6 and negative 5. And the variable parts are x, y to the fourth, and x squared z. All right, now we're going to evaluate some algebraic expressions. So to evaluate, we're going to plug in all the known values of the variables, then we use order of operations to determine the value. So we're going to evaluate the expression when x equals 2. And the expression is 5x to the third power. So we'll take 2 and plug it in for every instance of x. There's only one here, so we'll take 5. And I always take my substituted values and put them in parentheses when there's an exponent involved. All right, now order of operations, we'll start with the exponents. We got 5 times 2 to the third is 8, and multiply them out to get 40. Your turn, number 3. So we got 4x squared when x equals negative 3. So it's especially important when we have negative values to put them in parentheses. Because we're squaring x, that means we have to square the entire thing, negative 3. So negative 3 has to go inside the parentheses. When we square that, negative times negative is a positive, so this turns into positive 9. So we get 4 times 9, multiply them together, 36. Now in the next expression, we're going to have two variables to plug in. (4x plus 5y) when x equals 8 and y equals 9. So 4 times 8 plus 5 times 9. 32 plus 45. We get 77. Your turn, number 4. So plugging those values in, 4 for x, -2 for y. Multiplying out first, order of operations, we're going to multiply first. Multiplying those out, we got -12 on the left, -8 on the right. And the last thing we're going to do is add those two things together to get -20. Next example, we're going to evaluate AB divided by -2b when a equals -6 and b equals 4. Now plugging these in, we got -6 here times 4 divided by -2 times 4. Order of operations, we're going to start inside the parentheses. So that gives us -6 times 4 divided by -8. Now we've got multiplication and division across here. We're going to start working left to right. -6 times 4 is -24 divided by -8. Now negative divided by negative is a positive. 24 divided by 8 is 3, so we get 3 for that one. Your turn, number 5. -6d divided by 3c when c equals 2, and d equals -5. So let's plug in. We got -6 times d, so plug in a -5 there, divided by 3 times 2. Order of operations says inside the parentheses first. -6 times -5 divided by 6. Now we've got multiplication and division. We'll work left to right. So starting over here, -6 times -5. Negative times negative is a positive, so we get 30 divided by 6. And then finally divide to get 5. Next example, we're going to have some fractions here. And 4 different variables in this one. 3cd over 4 plus 2ab. And our values are a equals 1, b equals 5, c equals -2, and d equals 4. When we get this many variables, one of the biggest mistakes I see is people plugging in the wrong number. So you got to be careful now. So we got 3, and then c is -2, and d is 4. So there's a numerator, divide by 4, plus 2 times A, which is 1, and B, which is 5. Now notice we've got something that matches on top and the bottom, so we can cancel those out. 4 over 4 is 1, so we cancel those. So we're left with 3 times negative 2, so that's negative 6, plus 2 times 1 times 5. Now multiplication is next, so don't work left to right here, because we have addition here. Addition and subtraction is always last. We're going to multiply over here, and we get negative 6, plus 2 times 1 times 5 is 10. Add those together, and we get 4. Your turn, number 6. C squared minus 3a over b when a equals 8, b equals 2, and c equals negative 6. All right, plugging these in, got a negative value here, so I'm going to put that in parentheses, squared, minus 3 times a, so that's 3 times 8, over b, which is 2. Starting with order of operations, going to start with that exponent. So negative 6 squared is positive 36. Now over here we've got the division bars are grouping symbols, so we can start up top. Consider these to be in parentheses 3 times 8. So that's 24 over 2. Now we'll divide next, leaving subtraction for last. 36 minus 12, and then subtract to get 24. Now we're looking at some expressions that are a little bit more complex, and keeping in mind your order of operations becomes especially important here. C minus d squared minus 5ab, when a equals negative 2, b is 3, c is negative 4, and d is 1. Plug it in. Inside the parentheses, we've got c, which is negative 4, minus 1 for d, square that, minus 5 times a, which is negative 2, and b, which is 3. So let's start inside this grouping symbol here. Negative 4 minus 1 is negative 5. So that gives us negative 5 squared. Minus 5 times negative 2 times 3. Next, the exponent. Negative times negative is positive, so this is positive 25. Minus 5 times negative 2 times 3. Now we're going to leave the subtraction for last. Before we do that, we're going to multiply all these out. 5 times negative 2 times 3. That's negative 30. Now subtracting a negative, that's like adding, so 25 plus 30, add them together and we get 55. Your turn, number 7. So we've got b plus c squared minus 4ad, where a equals 2, b equals 8, c equals negative 5, and d equals negative 1. All right, let's plug these in. We've got b plus c, that's 8 plus negative 5. And we're going to square that, minus 4 times 2 times negative 1. Starting inside the parentheses, 8 plus negative 5 is 3, so that gives us 3 squared minus 4 times 2 times negative 1. Exponents next. 3 squared, 9 minus 4 times 2 times negative 1. Now again, we're going to leave that subtraction for last. Addition and subtraction are always last. Now we'll multiply across here. 4 times 2 times negative 1. That's negative 8. Subtracting negative turns into addition, so we got 9 plus 8, add them together, and we have 17. Now some of these expressions are going to involve fractions, and if we have an expression in the numerator and the denominator, we're going to work through those separately, using order of operations on each individually. Just remember that division bar is a grouping symbol, so what is on top and what is on bottom, you can consider them to be inside parentheses. And we're going to evaluate to get this down to a single number on the top and a single number on the bottom, and we'll either simplify the fraction or divide it out. So let's plug in 4 times c, so that's 4 times 2 minus d. So here it's really important to put the negative number inside parentheses, because now we're subtracting a negative. Never write it like this. You can't put 2 operations in a row like that. Got to put in parentheses. Over negative 1 times b negative 4. All right, let's look up top here. We're going to do order of operations on the top. And we've got multiplication and subtraction, so we'll start with the multiplication. So that gives us 8 minus negative 8 on top. And on the bottom, all we have is multiplication, so we might as well multiply this out. So negative 1 times negative 4 is positive 4. Right now on top, that turns into 8 plus 8 over 4. So that's 16 over 4 for the final answer. Your turn, number 8. Negative 4a over b plus c. When a equals 5, b equals 6, and c equals negative 4. So plugging these in, we got negative 4 times a, which is 5, b, which is 6, plus c, which is negative 4. Now on top of negative 1 times 4 times 5, that is negative 20. And the bottom, 6 plus negative 4 is 2. Now we've got a single number on top, single number on the bottom. Now we can divide and get negative 10. Right now we're going to look at some expressions with a little bit more going on here. Negative of 3c minus d squared over negative 4b plus 7a. We got a equals 2, b equals 3, c equals 6, and d equals negative 4. All right, let's plug all these values in. 3 times c, so that's 6, minus d squared, so that's negative 4 squared, put that negative 4 in parentheses. And on the bottom, negative 4 times b. Okay, order of operations on top. First thing, make sure you keep that negative out front. What I usually do is I'll just write the negative, write the fraction bar so I don't forget anything. All right, exponent first. Negative 4 squared is positive 16. So we got 3 times 6 minus positive 16. And the bottom, got a multiplication here, so that's negative 12. And since it's separated by addition, we can go ahead and do those at the same time. So it's negative 12 plus 14. Now on top, next step, we've got multiplication and subtraction, so we'll do the multiplication next. So keeping that negative out front, 3 times 6 is 18, so 18 minus 16. And the bottom, we'll combine these two to get 2. Next up, finish off the top, and that is negative 1. Your turn, number 9. Two b minus 3d all over c squared minus a. Where a equals 7, b equals 6, c is negative 3, and d is negative 2. So let's plug these in. 2 times b, which is 6, minus 3 times d, which is negative 2. All right, over c is negative 3, so negative 3 in parentheses, squared, minus a, which is 7. Now, order of operations on top, we've got multiplication over here, so that's going to be 12, subtracting, and then we can go ahead and do this multiplication to get negative 6 on the right. And over here, negative 3 squared, that's positive 9, so 9 minus 7 on the bottom. Now the top is going to convert to addition. Subtracting a negative turns into addition, so 12 plus 6 over 2 will finish off the denominator. Adding together the top, that gives us 18 over 2, or 9. Next up, we've got fractional coefficients in this one. Negative 2/3 times a squared minus 1/9 times b squared, where a equals negative 3 and b equals 6. So first thing I'm going to do is plug these in. So negative 2/3 times a squared, that's negative 3 squared, minus 1/9 times 6 squared. First thing we're going to do, order of operations, is evaluate the exponents. So we got negative 2/3 times 9 minus 1/9 times 36. Now, next thing to keep in mind is whenever you multiply a fraction by a whole number, you just multiply the whole number by the numerator. Leave the denominator alone, because this is the same as 9 over 1. So 2 times 9 is 18, so that gives us negative 18 over 3, minus 1 times 36 is 36, so 36 over 9. Next up, evaluate these fractions. They both divide evenly, so 18 divided by 3 is 6, that's negative 6, minus 36 divided by 9 is 4. Negative 6 minus 4, negative 10. Your turn, number 10. So we got negative 1/4 a squared plus 1/3 b squared, where a equals negative 2 and b equals 9. So let's plug it in. Now evaluate the exponents. Negative 2 squared is positive 4. So it's negative 1/4 times 4 plus 1/3 times 9 squared, 81. Right, now we'll multiply these. Negative 1/4 times 4, that gives us negative 4 over 4 plus 81 over 3. It's negative 1, 27. So 26 is our final answer there. Next expression. We've got negative 2/3 a minus 1/7 times BC minus AD. And we've got a equals 3, b is 6, c is 4, and d is 1. Plug it in. Negative 2/3 times 3 minus 1/7 times b times c, so that's 6 times 4, minus a times d. So let's start inside these parentheses. We're going to evaluate that. 6 times 4 is 24, minus 3. Varying this, you get 21. And now it looks just like the other ones. So we'll go ahead and multiply by the numerator, so that is negative 6 over 3 minus 21 times 1 on top over 7. Negative 6 over 3, that's negative 2. And negative, or subtracting, 21 over 7, which is 3. Subtract those, and we get negative 5. Your turn, number 11. One quarter A plus 3/5 times AC minus BD. We've got A equals 4, B equals 2, C is 7, and D is negative 1. Plug all these values in. 1/4 times 4 plus 3/5 times A times C, so 4 times 7, minus B 2 times D negative 1. Starting inside the parentheses, four times 7 is 28, minus 2 times negative 1 is a negative 2. You can go ahead, since we're separated by addition, I'm going to go ahead and evaluate this one. So 1/4 times 4 is 1, so we get 1, plus 3/5 times 28 plus 2. Adding those together, we get 30. So what I'm going to do now is I'm going to take this, since this is in the numerator, I'm going to go ahead and do the division first. 30 divided by 5 is 6. 6 times 3 is 18. We could have done that the way we did before by multiplying with the numerator. So 30 times 3 gives us 90. 90 divided by 5 is 18. So same answer either way. Add them together, and we get 19. So now we're back to the examples from the introduction. We're going to start off with a food stand. So we got the food stand selling pretzels and drinks. The owner created a formula for calculating total revenue in a day. And that formula is R equals revenue equals 2.5 P plus 1.25 D. Notice all the variables represent their quantities. R for revenue, P for pretzels, D for drinks. That way, when you look at the equation, you know exactly what everything means. All right, now, if the owner sells 78 pretzels and 123 drinks a day, what's the total revenue? Go ahead and calculate that. So we're given that it sold 78 pretzels and 123 drinks. So that means P is 78, and D is 123. So let's plug those values in. R equals 2.5 times 78 plus 1.25 times 123. Now we'll go ahead and multiply here and here. And when we multiply that out, we get 195 plus 153, 75. Add them together. $348.75. So the total revenue is $348.75. Now in chemistry lab, we're going to be working with a very famous equation called the ideal gas equation. So here's one form of it. The other form you might see is PV equals nRT. Find that by bringing the RT over here. Now P is the pressure in atmospheres. V is the volume of the gas in liters. R, that is the ideal gas constant, in which we're going to equal to 0.08. And this constant has different values depending on which units you're using. But with the units we're using, it's going to be 0.08 rounded. And then T is the temperature in Kelvin. So now we're going to go through, find the values, and then insert them into the equation in the correct spot. All right, so as I read through this thing, I'm picking out these values here. We've got 0.475 liters, so that's the volume. So there's V. Atmospheres, there's your pressure. Temperatures in Kelvin, so there's T. And then the ideal gas constant, 0.08. So there's the values, and we're going to plug them in here and find the number of moles. So on top we have 1 times 0.475. And the bottom, 0.08 times temperature, 273.15. I'm multiplying out on the top, it's just multiplying by 1, so that doesn't change the 0.475. And the bottom, 0.08 times 273.15 gives us 21.852. And now, since we're down to a single number on top, single number on the bottom, we can divide it out. And we get n equals 0.0217. And we can round that to about 0.02. So that means there's 0.02 moles of krypton gas in the sample. And that is it for today. Hope you all have a great day.